Good morning Year 8 and welcome to today's maths lesson. Let's start off with the starter as always. Can you find the area of this square where I've given you one length is 4? Can you find the area of this rectangle where I've told you the length is 7 and the height is 4? Can you work out 2.5 times 2.5 for me? And can you work out 2.5 times 2.5 times 2.5? Pause the video and have a go at those questions in your light blue books now please. Right, let's go through the answers. If it's the area of a square, we know that both lengths are exactly the same. So this length is 4, this length is 4, so my area is 16 centimetres squared. Notice that it's an area, so we're measuring it in centimetres squared. For the area of the rectangle, what calculation do I need to do, Mia? Great, this time I'm doing length times height, which is 7 times 4, which gives me 28 centimetres squared. For the next question, I asked you to find 2.5 times 2.5. Now the first thing I'm going to do is I'm going to multiply both of those numbers by 10. So that the calculation I'm doing is going to be 25 times 25. Now I can do that either using column method or I can use my grid method, I do not mind. But 25 times 25 is going to give me 625. But that's not the question. The question was, what's 2.5 times 2.5? So to work that out, I need to divide 625 by 10 and then by 10 again. So that's going to give me 6.25. We can do a quick sanity check. 2.5 is between 2 and 3. 2.5 is between 2 and 3. 2 times 2 would give me 4, 3 times 3 would give me 9, 6.25 is between the two. That sounds plausible. For the next question, I asked you to find 2.5 times 2.5 times 2.5. Well, we know that 2.5 times 2.5 is 6.25. So I'm now doing 6.25 times 2.5. I'm going to start off by multiplying that one by 100 and that one by 10 to get rid of my decimal places. So I've got 625 times 25. I can then work that out either using column method or grid method, I do not mind. 625 times 25 would give me 15,625. I want to put my decimal place back in now. To do that I need to divide by 10 to undo what I did here and then divide by 100, which will give me 15.625. Quick sanity check. 6.25 approximately equal to 6. 2.5 between 2 and 3. 6 times 2 would give me 12. 6 times 3 would give me 18. 15.6.25 is between the two. Sounds plausible. Okay, Year 8, in your light blue books, can you write the word volume in the middle of your page? And can you write me anything you know about volume? Pause the video for a few minutes. Anything formulae-wise, any definitions, where you might see it in real life, what types of shapes might have a volume, and what the difference between area and volume might be. Pause the video and write down anything you can think of now, please. Okay, here's some of the things that I thought of. The definition of a volume, I said, was the amount of space within a 3D object. So I said it had to be a 3D object, like a tin or a box, and the amount of space within it. Real life uses, I said you could have the volume of a rucksack if you're on Duke of Edinburgh, maybe the volume of a water bottle, volume of sand in a sandbox. Types of shapes that have a volume, always a 3D shape, but you could have cubes, cuboids, spheres, cylinders, as long as it's in 3D. Difference between an area and a volume, you might have guessed this by now. An area is a 2D shape, so it's measured in units squared, whereas a volume is a 3D shape and we measure it in units cubed. And some formulae you might have known, you might not have known. A cube is length times width times height. A cuboid is also length times width times height. A cylinder is the area of a circle, remember this from our areas of circle work, pi r squared times h, and a prism was area of base times height. Don't worry if you didn't know any of those, we're going to be covering that soon. Okay, year 8, in your dark blue books for me, can you write volume in the middle of your page, and around the outside can you write me your definition, an example, a non-example, and any characteristics of volume you can think of. Pause the video for a couple of minutes and have a go at that now, please. Right, let's fill in any gaps you might have. Your definition might look slightly different to mine, but mine was the amount of space contained within a 3D object, an object that is 3D. As long as you've got the words 3D and amount of space, I'm happy. Yours might look slightly different. I said an example. I drew some examples. I said here's a cylinder, here's a cube, the volume of the space inside those. Non-examples, I drew a square and said 2D shapes do not have volume. And characteristics, I said water in a fish tank, chips in a cylinder container, or sand in a box. Any of those. And we know it's measured in some kind of unit, for example, centimetres cubed. Please make sure you've got these notes in your dark blue books. Right, let's talk units of volume. Now I said volume is measured in centimetres cubed. Could be millimetres cubed, could be metres cubed, but it will always be something cubed. For example, here's my 1 centimetre cube. It's 1 centimetre by 1 centimetre by 1 centimetre. So one of these cubes has the volume 1 centimetre cubed. If I had 2 of them, it would be 2 centimetres cubed. If I had 3 of them, it would be 3 centimetres cubed. If I had 100 of them, it would be 100 centimetres cubed. Pause the video, year 8, and in your light blue books, can you write for me the volume of each of these 3 shapes? Pause the video for a couple of minutes and work that out now, please. Each of these little cubes means 1 centimetre cubed. And here's the answers. Please check your work and see how you did. Right, year 8, dark blue books for me. Can you write the title volume of a cube? Underneath, can you write the formula? Volume of a cube is length times width times height, which is sometimes shortened to L times W times H, which is LWH. When you've got that written down, please put your pens down and I'm going to go through an example, then you're going to do one. So here's my example. I've got a cube which is 11 by 11 by 11. I know my volume is going to be length times width times height. Because it's a cube, I know that my length times width times height are all exactly the same. So my volume is just 11 times 11 times 11, which will give me what, Jonas? 1,331. Great. Have I finished, Jonas? No, I need a unit in there, and my unit is centimetres cubed. Over to you, year 8, in your dark blue books. Can you have a go at this example for me? Pause the video for a couple of minutes and complete that now, please. Right, let's go through the answer. I've got a cube. My volume is going to be length times width times height. My length, my width and my height are all 15, so I've got 15 times 15 times 15, which gives me what, Emily? 3,375 centimetres cubed. Please remember you are doing length times width times height, 15 times 15 times 15. That is not the same as 15 times 3. 15 times 3 is far too small. Do not make that mistake. Okay, year 8, in your light blue books, A, B, C or D, what's the volume of the following shape if each of those little cubes is 1 cubic centimetre? Okay, we've got 8 little cubes. The correct answer is C, 8 cubic centimetres, not square centimetres. That would be area. Next one. What's the volume of this one? This time we've got 3 times 3 times 3, which gives me D 27 centimetres cubed. Now, if the volume of it is 64, how long must each of its sides be? Right, let's work it out. We need to do volume is a length times width times height. It's a cube, so we know that the length, the width and the height are all the same. If it was 2, we'd get 2 times 2 times 2, which would give me 8. That's too small. If it was 4, I'd get 4 times 4 times 4, which would give me 64. So that works. So the correct answer is B, 4 centimetres. 4 times 4 times 4. Okay, year 8, how good are you? The volume of this cube's 216. How long are each of its sides? Okay, the correct answer this time is C, 6, because we've got 6 times 6 times 6, which would give me 216. Over to you, year 8, in your light blue books. Please pause the video for 10 minutes and have a go at these questions for me. And these are the answers. Please check your work and see how you did. Please notice, that one should be meters, sorry. Please notice that when we've got that decimal place, we needed to multiply up and do 3.5, multiply that to give me 35, 35 times 35 times 35, and then divide by 1,000, divide by 10 3 times. For these two, I asked you to find the missing side. For this one, x was equal to 2, because if I've got 2 times 2 times 2, that will give me 8. And for the other one, x was equal to 4. 4 times 4 times 4 gives me 64. Right, we're going to do a quick Geogebra demonstration. Here is my cube. It's 10 by 10 by 10. And the volume is 1,000. 10 times 10 times 10. So what happens if I lengthen my cube to a cuboid? What's the volume going to be now? Pause the video, work out your answer. Interesting, my volume's doubled. I've now got 2,000 centimetres cubed. Is that what you'd have predicted? Let's go back to the start. How about if I go like this? What's my volume going to be now? Pause the video, write down your answer. Oh, once again, my volume's doubled to give me 2,000 centimetres cubed. Let's go back to the start. How about if I double this one and I double this one as well? What's my volume going to be now? Please pause the video and write down your answer in your light blue book. The volume this time is 4,000. So we've got 4,000 centimetres cubed this time. So I've doubled this one and I've doubled this length, and overall I've quadrupled the volume of my cube. Is that what you'd have predicted? Let's hide that. So my volume of a cuboid is the same as my volume of a cube. It's length times width times height. Only this time, the length, the width and the height may all be completely different numbers. Let's do another one just for fun. How big can we make it? What's the volume of this cuboid going to be? Pause the video and write down your answer now, please. 16,000 centimetres cubed. I've quadrupled two of my side lengths to 40 and 40, and overall my volume has increased by a power of 16. I've gone 16 times bigger. We're going to do one more. What happens if I halve this length? What's the volume now? Pause the video and write down your answer. Interestingly, I've halved that length and the volume's halved to 500 centimetres cubed. Is that what you'd have... Let's head back into the lesson. So in your dark blue books, can you write for me volume of a cuboid? Underneath, can you write volume of a cuboid is length times width times height, LWH, only this time length, width and height may all be different numbers. When you've got that written down, pens down, eyes on me, I'm going to go through an example, then you're going to do one. So the volume of my cuboid this time is a length times width times height, which is 8 times 10 times 6. Which gives me 80 times 6, which is 480. Have I finished, Tamsin? No, why have I not finished, Tamsin? I need to put in my units, 480 centimetres cubed. Over to you, Year 8, in your dark blue books. Have a go at this example for me. Pause the video and work it out now, please. Right, let's go through the answer. Volume, length times width times height. In this case, we've got 6 times 8 times 10, which you should have worked out is exactly the same as our previous one. All I've done is tilted my cuboid so it's up on its end. So again, 480 centimetres cubed. Over to you, Year 8, in your light blue books. Please pause the video for 10 to 15 minutes and have a go at these 3 sections for me. Find the volume of the cuboids at the top, find the volume of the cuboids in the middle, and then can you use your answer from B? Can you find the volume of these shapes for me? Pause the video and answer those questions now, please. And these are the answers. Please check your work and see how you did. One final question for you. A blue cuboid is constructed that is half the volume of the green cuboid shown. Which is the correct cuboid? Pause the video, have a little think back to our Geogebra demonstration and see if you can work it out. And the correct answer I was looking for is A. Think back to our Geogebra demonstration. We worked out if we just halved one of our lengths, for example 4 to 2, our volume halved as well. So if I want a blue cuboid that is half the volume of the green one, I need A, which is 2 by 2 by 7. You could have also worked it out that the volume of this one was 56, the volume of this one was 28, and 28 is half of 56. And that's the end of today's lesson. Please head over to Google Classroom and submit today's exit ticket. Thanks for listening, Year 8, and have a wonderful day. Goodbye.